Hi everyone, I am Engineer Usman. Welcome back to my channel, Gradelog by Usman. Today, we are going underground to discover what's really happening beneath construction sites. Most people only see the roads, buildings, and villas above the surface. But beneath our feet, an entire hidden world is under construction every single day. Underground pipelines, drainage systems, sewer networks, electrical conduits, firefighting lines, irrigation networks, and massive utility connections are all carefully installed before any project is completed. This hidden infrastructure is one of the most important parts of modern construction. Everything starts with planning. Before excavation begins, engineers study drawings, utility layouts, IFC details, and survey coordinates carefully. Levels are checked, underground clashes are identified, and the complete utility route is marked on site before machinery starts working. Every trench depth, pipeline slope, invert level, and connection point must be planned accurately before excavation begins. In many projects, engineers also coordinate between civil, MEP, infrastructure, and roadwork teams to avoid conflicts between different underground services. Once the area is ready, heavy excavators begin digging deep trenches across the construction site. Some excavations are shallow, while others go several meters underground, depending on the type of utility being installed. For deeper excavations, temporary access ramps may also be created for machinery and manpower movement inside the site. Excavation work may look simple from the outside, but underground construction is extremely technical. The soil conditions can change suddenly. Loose sand, wet soil, groundwater seepage, hard rock, and existing underground services all create different challenges for the construction team. In some locations, dewatering systems are installed to remove underground water and keep the trench dry during pipeline installation. Safety also becomes a major priority during deep excavation work. In many areas, steel trench supports, sheet piling, and shoring systems are installed to prevent soil collapse and protect workers inside the trench. Engineers continuously inspect the excavation before allowing installation activities to continue. Gas testing, confined space monitoring, and permit systems may also be required for certain underground works. After excavation is completed, survey teams carefully check the trench levels and alignment. This stage is extremely important because underground drainage systems rely completely on gravity flow. Even a small mistake in slope can stop water from flowing properly inside the pipeline system. Using total stations, laser levels, and leveling instruments, engineers ensure every section remains perfectly aligned according to the approved design. After level approval, bedding materials such as sand or granular base is placed at the bottom of the trench to provide proper support and protect the pipeline from damage. Once the bedding is completed, the underground pipes are lowered carefully into the trench using excavators, cranes, or lifting equipment. Large pipes are connected one by one while workers secure every joint and maintain the correct alignment throughout the route. Depending on the project requirement, different types of pipes may be used underground, including HDPE, UPV. Hi everyone, I am Engineer Usman. Underground depending on the project requirements, including HDPE, UPVC, GRE, ductile iron, and reinforced concrete pipes. Different pipelines serve different purposes beneath the ground. Some pipelines carry stormwater during heavy rainfall. Others transport sewage safely away from buildings and roads. Additional conduits also protect electrical, fiber optic, and communication cables beneath the surface. Pressure pipelines are installed for water supply, irrigation systems, and firefighting networks. As the underground network expands, manholes, valve chambers, and inspection chambers are constructed along the pipeline route. These structures provide future maintenance and inspection access to the underground system. Concrete chambers, benching works, covers, and access ladders are installed carefully while maintaining proper pipe connections and levels. Waterproofing systems may also be applied to underground chambers to prevent leakage and groundwater penetration. Before the trench is closed, engineers inspect and test the complete underground system. Pipe alignment, slope, invert levels, flow direction, and joint connections are checked carefully to ensure everything functions properly before backfilling begins. Some pipelines also undergo pressure testing, air testing, hydro testing, or CCTV inspection depending on project specifications. Quality control engineers document every stage using inspection reports, test records, and as-built survey data. Once approval is completed, the trench is backfilled layer by layer using selected materials. Compaction equipment is then used to strengthen the soil and prevent future settlement above the underground utilities. Field density tests are also conducted to verify proper compaction before roadwork or concrete activities continue above the trench. Finally, road base asphalt, interlock, landscaping, or concrete surfaces are restored above the completed underground utilities. After all the work is completed, the entire underground infrastructure disappears beneath the surface. Roads are restored, buildings continue rising, and people move around without ever seeing the hidden systems below them. But without this underground construction work, modern cities simply could not function. Every successful city depends on a strong underground infrastructure network, working silently beneath the surface every single day. Thank you for watching. Subscribe to Gradelog by Usman for more real construction videos, excavation works, underground infrastructure projects, pipeline installations, civil engineering site activities, and technical construction updates.